Hello, this is a walkthrough for the Maths Paper 2 from Edexcel. It's a calculator paper, it's the higher level and it's from June 2023. Question 1. Work out the value of 25 minus square root of 43.87 over 6 plus 2.1 squared. So I need to enter this into my calculator carefully. I'll press fraction button first of all, then on the top of the fraction I'm going to type in 25 minus 43, square root sign, and then enter 43.87 inside the square root. Go to the bottom of the fraction, enter 6 plus 2.1 squared. Check that my calculator looks exactly like it does on the question. If it does, press equals and your answer should come out as 1.7652, etc. So you'd make sure your answer looks something like that. You will need to put at least at least 4 or 5 digits there, I think, before they'll be happy with that. Part B, work out the value of the reciprocal of 0.625. The reciprocal of a number is just 1 over that number. So putting that into the calculator, we get 1 over 0.625. It comes out as 8/5, but it wants the value, so I'm tempted to put it as a decimal, which is 1.6. You can press the SD button to find that. Question 2. Write 60 as a product of its prime factors. Prime factors are all the numbers it divides by that are prime numbers, and you should know the prime numbers are 2, 3, 5, 7, not 9, 11, 13. That's probably enough. So writing it as a product of its prime factors, I write down the number 60 and I put an inverted tree, so 2 branches coming from the 60, and I want 2 numbers that multiply to give to 60. The obvious ones are 6 times 10. Okay, and I'm looking now, are 6 or 10 in my list of prime numbers? No, they're not. So I need to go again from each of those numbers. So for 6, I've got 2 numbers that multiply to give 6. 2 times 3. Are they in the prime list? Yes, 2 is, so circle it. And also 3 is, so I'm circling that. So I can stop once I've circled. I go over to the number 10, which hasn't been used yet. I'm putting 2 branches for that. And 2 numbers that multiply to give 10. 2 times by 5. Both of those prime numbers. And so my 60 as a product of its prime factors is 60 times by, I'm writing them in order. Sorry. Let's write that a little bit more clearly. 60 is equal to 2 times another 2, it's in there. Then there's a 3, then there's a 5, and that's my answer. Question 3. There are 48 counters in a bag. There are only red counters and blue counters in the bag. Number of red counters to the number of blue counters is 1 to 2. Helen has to work out how many red counters are in the bag. Well, 1 to 2, the ratio of 1 to 2 is 1 out of 3. Okay, there's 1 part is red out of every 3 counters. Okay, Helen says she has to work out how many red counters are in the bag, and she says there are 24 red counters. So a third of the counters must be red, and 1/3 of 48 is 48 divided by 3, and 48 divided by 3 is 16, which is not 24. Okay, Helen is not correct. There should be 16. Question 4, and we've got an inequality, and let's zoom in on that one. So it says, and we read from the n when we read an inequality, n is greater than or equal to -2 and less than 5. And n is an integer, a whole number. Write down the greatest possible value of n. Well, 5 is the biggest number in the numbers that we've been given there, but n has to be less than 5. Now 5 is not less than 5, but 4 is less than 5, and that's the biggest value, so 4 is my answer. Part B. On the number line below, show the inequality m is greater than or equal to negative 4, and less than 1. Okay, so it's going to be greater than or equal to to negative 4. So we put a circle at negative 4, but it includes negative 4, so we colour it in, and then it goes up to 1, but does not include 1 because it's less than 1, and then we join, hopefully with a ruler, the straight line, and that's the answer. Final question on these inequalities here is solve 2/5 g minus 4 is less than 6. And this is like an equation, but we need the inequality sign there. So we're going to get rid of that minus 4 by adding 4 to both sides. That gives me 2/5 g minus 4 plus 4 is nothing, less than 6 plus 4 is 10. And then to get rid of the 2/5, I'm going to divide by 2/5 using my calculator. G is less than, we're also dividing the other side by 2/5, and 10 divided by 2/5 is 25. So my answer is G is less than 25. Here is a triangle and a rectangle. All the measurements are in centimetres. The area of the triangle is 10 centimetres squared greater than the area of the rectangle. Work out the value of x. So this bit of information might be useful later, but we need to compare the areas of these two rectangles. For a triangle, it's half the base times the height, so it's half times by 8, the base, times by the height, 6x. And simplifying that, half of 8 is 4, times by 6 is 24, so that one's 24x. And the right hand one is just because it's a rectangle, base times height, that's the base, times by the height, and I multiply that out, I get 5 times 4x is 20x, and 5 times 1 is 5, so it's 20x minus 5. But it says that the area of the triangle is 10 centimetres greater than the area of the rectangle. So 24x is equal to the 20x minus 5 of the rectangle plus an extra 10. It's 10 bigger than this rectangle. Okay, so now I need to simplify that. 24x is equal to 20x minus 5 plus 10 is the same as plus 5. And then I'm trying to get x on its own, so I'm going to first of all get rid of this 20x by taking 20x off both sides. That gives me 4x is equal to 5, and then dividing by 4 gives me x is equal to 5 over 4, or as a decimal that would be 1.25. Question 6. Last year a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. Weight of paper recycled to weight of glass recycled is in the ratio 12:7, and we've got to calculate the weight of glass. The weight of glass, okay. So 57% of the waste of that 800 kilograms was paper and glass. So 57%, that's 57 out of 100, times by 800 is 57 over 100 times by 800 gives me 456 kilograms of waste of that's paper and glass, isn't it? And also we've got this ratio of paper to glass, and that is 12 to 7. So the ratio of paper to glass is 12 to 7. Adding the parts of the ratio together, I've got 19 parts. And I've got to split the 456 kilograms by 19. 456 divided by 19 gives me 24 kilogram per part. And we're interested in the glass, so I've got 7 parts, each worth 24 kilograms. 7 times 24 is 168 kilograms. Question 7. A number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. 1 decimal place means it will be 12.6 will be the number below 12.7, then 12.8 will be above. Halfway in between gives me 12.65 and 12.75. Question 8. Tamsin buys a house with a value £150,000. The value increases by 4% each year. Rachel buys a house with a value of £160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. Okay, so this is compound interest. We've got 4% increase, so that's 100 plus 4%, which is 104% of what it was worth at the start of a year. And as a multiplier, as a decimal, that is 1.04 divided by 100. So my multiplier here is 1.04, and for Rachel it increases by 1.5%, which is 101.5%. That means a multiplier of 1.015. Okay, I've got to be a little bit careful that I make sure that I keep the digits in the same order. So I've got 2 multipliers. So for Tamsin, the new value at the end of 2 years is 150,000 times by 1.04 to the power of 2. Okay, so banging that into my calculator, what do I get? 150,123 times by 1.04 squared gives me 162,240, and for Rachel we've got 160,000 times by 1.015 squared, and that comes out as let me just do that. That's 160 times by 1.015 squared, and that comes out as 164,836, and it says whose house, so Rachel's house has greatest value. This question is about a cumulative frequency table. What I've done is I've put both this question and the graph you have to draw on one page. So here it is condensed a little bit. It says at the top, the cumulative frequency table gives information about the ages of 80 people working for a company. 80 people working, okay. On the grid opposite, draw a cumulative frequency graph for this information. So we've got to translate this information onto the graph. That means I plot at the upper end for cumulative frequency, so I'm plotting 30, at 30 years I'm plotting 20, at 40 years I'm plotting 48, 50 at 64, 60 I'm plotting 75, and at 70 I'm plotting 80. So those are really the coordinates that I'm going to plot. So let's do them. 30, 20 is here, and then 40 and 48 will be there, and then 50 and 64 will be here, and then 60 and 75 will be there, and then 70 and 80 will be there. I've also got a plot down to 20, 0, and what I need to do is I need to make sure I do this but in a curve and not as a straight lines using a ruler. Okay, so I'm trying to plot it in. As long as it's roughly smooth, it's okay. It should go through every single point that you plotted. Okay, so we've done that now, and then it says use your graph to find an estimate for the median age. Well, there's 80 people in there, and the median value is the middle value, so we want the 40th person. So if we look on the cumulative frequency at 40 and we go across, I'm going to zoom in here to make it more accurate, and then plot down. I need to move up a little bit. Obviously use a ruler for this bit. I'm drawing freehand at the moment, and the median value is 37 years of age there. Probably as well to underline that to make sure that they're really clear what your answer is. Question 10. A bias coin is thrown 60 times. The table shows information about the number that the dice lands on each time. Gethin throws the dice twice. Work out an estimate for the probability that the dice lands on 6 both times. Well, the probability of getting a 6 is 15 out of the 60 throws. Okay, so an estimate of the probability of doing that twice means it's 15 out of 60 once, and then multiplied by it again. And if I multiply that out, 15 over 60 times by 15 over 60 equals 1 over 16. Okay, so an estimate for the probability the dice will land on 6 both times is 1 out of 16. Part B of that says Sally is going to throw the dice n times and record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? Well, to be a more reliable estimate, we've got to throw it more times, because we'll have a better idea about what it's likely to land on if we say throw it 120 times or 100 times. So n must be bigger than 60. So I've written it down as an inequality, but you could write that in words. Question 11. Use algebra to solve the simultaneous 2x plus 6y is equal to 5 and 3x minus 4y is equal to negative 12. So what I always do is I label my equations, equation 1 and equation 2. I can see that the numbers before the x's and the numbers before the y's are not the same. I can't easily convert one into the other, so what I'm going to do is I'm going to do equation 1 times by 3 to turn 2x into 6x, because I can also turn the 3x into a 6x. So 1 times 3 is 6x plus 6 times by 3 is 18y, and 5 times by 3 is 15, and that's equation 3. And then I'm going to take equation 2 and I'm going to multiply it by 2. 3x times by 2 is 6x, which is what I wanted, and then negative 4y times by 2 is negative 8y, and then negative 12 times by 2 is negative 24. I can now subtract because they're both the same, so I'm going to do equation 3, take away equation 4, and 6x take away 6x is 0, and 18y take away 8y, 18y take away, it's not take away 8y, it's take away negative 8y, which is the same as 18y plus 8y, which is 26y. So I've got 26y, And then I've got 15 take away negative 24. That's the same as 15 plus 24, which is 39. Okay, so 26y is equal to 39, and dividing it by 26 gives me y is equal to 39 over 26, which is, on a calculator, you could work that out and it will be 1.5. So 1.5 is the y value. We now need to just find the x value. So I'm going to substitute y equals 1.5 into equation. The easiest looking one is equation 1. So I want 2x plus 6 lots of 1.5 is 6 plus 3, which is 9, equals 5. Take away 9, and I've got 2x equals 5 take away 9 is negative 4, and then halving that gives me x is equal to negative 2. Question 12. The points A, B, C and D lie on a circle. Centre O. A, B, C, D is a rectangle. AB is equal to 8 centimetres and BC is equal to 10 centimetres. Work out the circumference of the circle. Circumference equals pi times the diameter. I need the diameter then for this. The diameter I can look at here, a straight line through the centre of the circle to the circumference on both sides. So I need to work out the length AC. This is a right angle triangle, and I've got 8 there and 10 there. I can use Pythagoras, so I want the square root of 10 squared plus 8 squared, which is equal to 12.806, and then the circumference will be equal to pi times by 12.806, which is 40.232, but it wants it 3 significant figures, so that will be 40.2 centimetres. ABC is a triangle. Calculate the side of angle BAC. BAC is the one where A is in the middle, so there we go, it's A, and it's not a right angle triangle, so I can't use trig or Pythagoras, but I can use the sine rule here. So sine of A over little a is equal to sine of B over little b, which is equal to sine of C over little c. Opposite sides to the angle are labelled the same, so I'm just labelling those now. Now I don't know it for A at the moment, but I can work out C, and then from that I will have enough angles to work out what A is. So I'm going to do sine B over B is equal to sine C over C. Sine B is sine of 70 over little b is 18 is equal to sine C we don't know over little c is 15. Rearranging that, I've got multiplied by 15, I've got sine C is equal to 15 times by the sine of 70 over 18, and that works out as 15 sine 70 over 18 equals 0.783077. That's sine C. I'm going to leave my values in my calculator, and C will be the inverse sine of 0.783077, and shift sine, the answer is 51.5 will go to, because it's only wanting an answer to one decimal place. So I now know that that's 51.5 degrees, And to work out what A is 180 degrees in a full circle minus 70 minus 51.5, and that works out as 58.5 degrees. So the answer is 58.5 degrees. Okay, we've got a fraction here with a quadratic at the top and the bottom. To show that this fraction can be written in the form of two linear expressions, top and bottom, and we've got to make sure that the a, b, c, d are integers. So I'm going to factorise both of the top and the bottom. So x squared minus x minus 6 is equal to, let's put the brackets in, I know it's going to be x and x. I want two numbers that give 6, so 1 times 6 or 2 times 3. It's a negative 1x, so I need them to be 1 apart. It's going to be 2 and 3, but one of these is going to be negative. The negative number must be bigger because we've got a negative here. So I'm going to have negative 3 and add 2. And just checking, negative 3 times 2 is negative 6. And then negative 3 times x is negative 3x, and 2 times x is 2x. So yeah, that is correct. And then on the right hand side now, I'm going to do the bottom, the denominator, and I've got 2x squared minus 5x minus 3, and that is equal to, it's not going to be x and x this time because of the 2x squared, so it's going to be a 2x and an x. And what two numbers that multiply to give 3? Well, it can only be 1 times 3, and 2 times 3 would give me an answer of 6, so that's going to be very close to 5x, so I think that's going to be right. So I'm going to put a 3 here and the 1 there, and it needs to be very negative, so probably that way round. Let's just check. 2x times by x is 2x squared, 2x times by negative 3 is negative 6x, 1 times x is x, and then 1 times negative 3 is negative 3. Negative 6x plus x is negative 5x, so I know that that's right. So I'm going to rewrite my fraction from the start as x minus 3, x plus 2 at the top, and I'm replacing 2x squared, etc., with 2x plus 1, x minus 3, and I can see that we've got two brackets that are the same, top and bottom, so I can cancel those out, and I need to write down my answer clearly as x plus 2 over 2x plus 1. Here we've got a is 1, b is 2, c is 2, and d is 1. Oh, another question down there. First four terms of a quadratic sequence. So this is not a linear sequence, this is a quadratic sequence. 3, 9, 17, 23. Find an expression of n for the nth term of the sequence. So it's jumping up plus 6, then it's jumping up plus 8, then it's jumping up plus 10, and from 6 to 8 we're jumping up 2, and from 8 to 10 we're jumping up 2. So half of 2 is 1, and 1 times by n squared is just n squared. So I know that my rule is going to start n squared. So if I write out n squared, I get 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. But the values that we've got in our sequence are 3, 9, 17, and 27. So if I take away here, 3 take away 1 is 2, 9 take away 4 is 5, 17 take away 9 is 8, 27 take away 16 is 11. This is a sequence that jumps up 3, it jumps up 3, it's jumping up 3 each time. That means that is 3n. If I go back 3 from there, I get to negative 1. So it's 3n minus 1. I need to join those two together. So my sequence is 3n squared, sorry, not 3n squared, do apologise, n squared plus 3n minus 1. And that is my answer. Histogram. So The histogram gives information about the number of hours some students used their phones last week. The histogram is incomplete. 28 students used their phones for between 30 and 40 hours. So that's this group here, 30 to 40 hours. There were 28 students in there, and with a histogram, the frequency or the number of people is the area inside that histogram. So I also know that the frequency density is equal to the frequency divided by the class width. So if I'm trying to find out what the frequency density is for 28 students, I've got a frequency of 28 divided by 30 to 40 is a width of 10, which is 2.8. That means the value here, the same height as that, is 2.8. So that value is 3, that's 4, that's 2, that's 2, and that's 1. So we now need to show 24 students use theirs between 40 and 60. So in this region here, we want to have 24 students in total. So the frequency density will be equal to the frequency 24 over the class width of 20 this time. This is for this one. 24 divided by 10 will be 2.4. So 24 divided by 20 is 1.2. So the value that we want is 1.2. That would be here. I need to go across, obviously use a ruler, and down, and that's completed the histogram. The last bit says, no students use their phone for more than 60 hours. Work out the total number of students. Well, no one's in this region here is what they mean by no more than 60 hours. I need to work out the areas of these two blocks because we haven't worked those out yet. So we've got a height of 1.6 times by a width of 20. That gives me 32 people in there. And then I've got a height of 3.6 times by 10. That means there's a total of 36 people in there. So I now need to add up for part B all those values, 32 plus 36 plus 28 plus 24, and that would give me 120. Question 17. The equation x to the 4 minus x squared minus 5 equals 0 can be written in the form x equals the 4th root of x squared plus 5. Well, I need to get x to the 4 on its own first of all, so I'm going to add, let me just write, I'm going to add the x squared and add the 5 on to both sides to make those shift to the right hand side. So it becomes x to the 4 on the left equals x squared plus 5, and then I'm going to take the 4th root to turn the x to the 4 into an x, and I want the 4th root of x squared plus 5, which is what we wanted here, so we've shown it. Question part B says, starting with x0 is equal to 1.5, use the iteration formula 3 times to find an estimate for a solution 2. So what we're going to do is we're going to start with, we're going to work out what x1 is, we're going to work out what x2 is, and then we're going to work out what x3 is. So x1 is equal to the 4th root of the number before the x0, 1.5 squared plus 5, and that works out as 1.641. Be careful how you enter this in. If you're careful the first time, you can scroll back and change that 1.5. So we now want the 4th root of our new value, which is 1.641 squared plus 5. We put that in the calculator and we should get 1.665, and then one final time, the third time, we do 4th root of 1.665 squared plus 5, and that comes out as 1.670, and that is the answer that we're looking for. Question 18. we've given two sets of ratios here for 2a to 5c and also for 4b to 7c. The common letter here is c, so we're going to try and change them so that we've got c as the same value. So I'm going to change them all so that I've got a ratio of not 2a to 5c but just a c to something here. So to do that, I've divided by 5. That gives me 2 divided by 5 is 0.4. 0.48 to c is the same ratio as 6 to 25, so it is 6 to 25. And for 4b to 7c, if I want to turn that into a c, I've divided by 7. Well, 4 doesn't divide nicely by 7, so I'm going to leave that as a fraction. 4/7 of b to c is in the ratio 20 to 21. I now need to try and make the c values in number wise the same. So I'm going to multiply here by 25 and here by 21. So what we will get when we multiply those out is 21 times by 6, sorry about that, 21 times by 6 gives me 126, and 25 times by 21 will give me, let's just type that in, 500, no it's not 500, it's 525, that's right. 20 times by 25 is 500 here, and 25 times 21 is the 525 that we've got for C already. So we've now got C values of 525, so we know C is equal to 525. We've got B values of, where we've got B, we've got 4/7 B is equal to 500. So that means B must be dividing by 4/7. Dividing by 4/7 will give me 875. And then the A values, we've got 0.4A is equal to 126. The A is equal to 126. So dividing by 0.4 gives me A is equal to 315. So I've got B is equal to 875, C is 525, and A is 315. And I need to show that A plus B is to B plus C is 17 to 20. Well, A plus B is 315 plus 875, which is 1190. And B plus C is 875 plus 525, which is 1400. And if I simplify that, I will get 17 to 20, which is the ratio that they wanted. Simplifying it with the calculator, probably the easiest way is to do 1190 over 1400. Put it in your calculator and it will simplify to a fraction that says 17 over 20. It's not really equivalent, but it will help you simplify those values. Question 19 is a right angle triangle. AB is equal to 9.3 centimetres, correct to the nearest millimetre, and 12.6 centimetres for AC, correct to the nearest millimetre. Calculate the lower bound for the size of the angle. So I need the upper and lower bounds for each of these. So LB for 12.6 will be, to the nearest millimetre, will be 12.55. And the upper bound will be 12.65. For the AB, I've got 9.25 for the lower bound, and upper bound will be 9.35. To get the smallest value, the lower bound for the size of the angle, I need the upper bound here and the smallest value there, because we're going to do cos of, is it a J? It's opposite, isn't it? It's not cos, it's sine, isn't it? So because this is hypotenuse and that's opposite, which is so. So sine of x is equal to opposite over hypotenuse. I want this value here, the opposite side, to be as small as possible. So sine x is equal to, the smallest value is 9.25 over, and I want this value here to be as big as possible. So that will be 12.65. So x is equal to the inverse sine of 9.25 over 12.65, and that works out as 46.989 degrees. Question 20. Okay, this is a question on vectors. So we've got OT is equal to A, RT is equal to B, and M is the point on OR such that OM to MR is 2 to 3. So in other words, that's 2 parts, that's 3 parts. Express MT in terms of AB. Well, to go from M to T, I need to go 3/5 of the way of OR rather, 3/5 of that distance from O to R, and then I need to go down B plus the whole length RT. Okay, so first of all we need to work out what OR is. OR is the same as going from O to T and then back to R. So it's OT minus RT. Okay, or yeah, minus RT because it's backwards RT. And OT is, we've already said what, have we said what OT is? OT is A minus, and RT is B. Yeah, is B. So A minus B. So going back to this one here, we've got MT is equal to 3/5 of A minus B plus RT, and RT is B, isn't it? So expanding that, I've got 3/5 A minus 3/5 B plus B, and that will simplify to, there's only one set of A's there, so it's 3/5 A minus 3/5 plus B is the same as plus 2/5 B, and that's my answer. Question 21. Here is the graph of y equals f of x, and on the grid below draw the graph of y equals f of x minus 4. That means I'm taking 4 away from all the y values. I need to shift my graph down 4 spaces. So I need to start at -4. So it's going to start at -4 there. It's going to go across 1 and then diagonally down again. Everything's 4 spaces below. So that's correct. On the grid below, draw the graph of y equals f of -x. Well, the original graph looked like that. And all we're doing is we're changing the x value from positive to negative. So we want our graph to be, this value goes to here, this value goes to here, this value goes to here. So our graph will look like that, and I'll just remove the original graph that I've sketched on, so it looked like that. There are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. So 4/5 of the pens are blue, and the red ones, there's 1/5 of the pens are red. Reader takes at random 1 pen from the box. She records the colour of the pen and then she replaces it in the box. Rita does this n times when n is greater than or equal to 2. So the probability of getting a blue is 4 over 5, and the probability of getting a red with one go is equal to 1 over 5. Don't know why I did that bracket there. Okay, write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. Now for this to happen, she can't get all red and she can't get all blue. And the probability of getting all blues would be 4 over 5 times 4 over 5 times 4 over 5 times however many times she got a blue. So to the power of the number of times that she does that. And the probability of getting all reds, similarly, is going to be equal to 1/5 to the n. Now those are the only ways she can't fulfill this thing about getting a blue pen at least once and a red pen at least once. The total probabilities add up to 1, so I need to subtract from that 4/5 to the n and also subtract from it 1/5 to the n. And that's the answer. Here are three similar triangles, ABC, ABG, ACF and ADE. ABCD and AGFE are straight lines. AB to BC to CD is 1 to 2 to 3 in the ratio. Show that the area of ABG, area of BCFG and CDEF, well those bottom two, those two are the trapeziums, aren't they? So if I look at the 1, 2, 3 triangles, the side lengths down the right hand side from A at the top is 1, 2, 3. So this one is 1 plus 2, which is 3. This one is 1 plus 2 plus 3, which is 6. So the ratio of the lengths is 1 to 3 to 6, but the areas of those triangles is 1 squared, which is 1, to 3 squared, which is 9, to 6 squared, which is 36. Okay, so the ratio of the areas of the triangles is 1 to 9 to 36. But the ratio of ABG, it will be 1, 2, area of BCFG will be 9. Okay, the area of that triangle, take away AGBF to get our thing. So it's 9, take away 1. And the area of this trapezium here is the area we've given for the biggest triangle, which is 36. Take away the area of AFC, which we've already said was 9. So simplifying those, I've got 1, 2, 9 take away 1 is 8, 2, 36 take away 9 is 27, which is what we wanted here. Hopefully this is the final question. So the diagram shows identical rectangular octagons joined to enclose a shaded shape. Each octagon has side lengths of A. So we've got a length here of A. Oh, hang on, let me write on that. So I want to edit. And I've got a length of A of here. Each side length is A. Okay, so that corner there is A. And what we've got here is we're going to try and find out the area of the shader's shape. Okay, we've got a square with 4 triangles, but if I break each triangle up into right angle triangles, because they're easier to deal with, I've got 8 little triangles. And if I think about one of those triangles, if I know that that side is A, these angles here are 45 degrees. And if I think about that side being the adjacent and this one being the hypotenuse, cos of 45 degrees is equal to the adjacent over the hypotenuse, which is little a. In other words, the adjacent is equal to cos 45 times by a but cos 45 is root 2 over 2a. So I know that the length of that the adjacent side is root 2 over 2a. So if I'm wanting to work out the lengths here, I've got this value here is root 2 over 2a, and the whole length there is well, let's not get into the whole length of that for now. So I know one side of the triangle. To work out the area of the triangle, of that triangle, it's base times height divided by 2, that's half, times root 2 over 2a, times by root 2 over 2a, which is root 2 times root 2 is 2, so half times 2 is 1, and then divided by 2 divided by 2, so there's a 4 at the bottom and there's an a squared at the top. So I know that the area of the little triangle is a squared over 4, and we've got 8 of those in our shaded thing. So I want 8 times a squared over 4 gives me 2a squared, and that's the 8 of those. Okay, so I'm just going to circle that because that's the important result there. Now, we've got to add that onto the area of the square that we got. But if we look at the lengths of the square, the sides are a. I've got root 2 over 2a for each little bit. So the whole length of that is double that, which is root 2a. And then we've got another length of a there. So the side of the square is a plus root 2a plus a, which is side length is 2a plus root 2a. Okay, and that is 2 plus root 2 lots of a, and the area of the square will be that times by itself. So I've got 2 plus root 2 times by 2 plus root 2, and a times a is a squared. Expanding the brackets, what we've got here is 4 plus 2 root 2 plus 2 root 2 is 4 root 2, plus root 2 times by root 2 is 2, lots of a squared, and that is 6 plus 4 root 2, lots of a squared. And we've also got a 2a squared there, so we want 2a squared plus 6 plus 4 root 2 a squared, and that is, let me just create some space at the bottom there. That is equal to, how many a squares have I got? Well, I've got, I can factor, no, that's 2a squared, hang on, not doing very well there. 2a squared plus 6a squared plus 4 root 2 a squared, which is equal to 8a squared plus 4 root 2 a squared, and I can factorise that, so I'm going to have to go up here, which is 2, I can divide both by 4, sorry, brackets 2a, no, hang on, I can divide both by a squared as well, can't I? So I can put an a squared outside, 2 plus 4 divided by 4 is 1, so it's plus root 2 a squared. So it's a bit messy that, so I'm going to write over here what I've got, 4 brackets 2 plus root 2 lots of a squared, and that is in the format that is shown there. So we've finished that, well done. Now you would go back obviously and check that you've not made any mistakes, and hopefully you've got enough time to do that. Okay, thank you very much.